It's extremely likely that hydrothermal vents, Enceladus, might harbor bacteria similar to those seen on Earth. The icy shell that surrounds Saturn's moon Enceladus has long piqued the interest of astronomers. Based on data gathered by NASA and the European Space Agency's Cassini-Huygens mission, the shell could be concealing a large underground ocean composed primarily of salt water beneath it, which tantalizingly could potentially contain life. Cassini's observations of Enceladus, which revealed that the moon is emitting plumes of methane gas, suggest that the moon's subsurface oceans may be habitable to microorganisms, similar to those found on planet Earth. Specifically, we wanted to know if Earth-like bacteria that consume the dihydrogen and make methane could be responsible for the very huge amount of methane found by Cassini. However, determining the correct solution is far from straightforward. Scientists built mathematical models to examine if methanogenesis could account for the data obtained by Cassini and found that it could. Their conclusion: microbial hydrothermal vent activity, or processes that would entail alien microbes, could be responsible for the methane found by Cassini. During hydrothermal activity, cold salt water seeps into the ocean floor, where it is warmed by nearby sources of heat, such as magma, and then bubbles up into the atmosphere. This water is then ejected out of vents in the ocean floor, a process that slowly releases methane into the water over time as it passes through the vent. Approximately 80% of this methane is produced by microbes that use the heat as a source of energy, converting carbon dioxide to methane. Not only could we determine whether Cassini's observations are consistent with an environment that could support life, but we could also make quantitative predictions about the observations that would be expected if methanogenesis occurred on Enceladus's seafloor. Obviously, we are not coming to the conclusion that life lives on the ocean of Enceladus. The researchers were more interested in determining the likelihood that Enceladus's hydrothermal vents might be hospitable to Earth-like bacteria. To put it another way, we can't rule out the life theory as being exceedingly improbable. In order to rule out the existence of life, we'll need additional data from future missions. Astronautic missions to the stars, discoveries in the unknown, and questions about our own existence are all possibilities. If any of these intrigue you, please subscribe to our YouTube channel, Facts Pulse, and continue your exploration of the vastness of the universe. It's an interesting new piece of study that demonstrates how little we know about Saturn's icy moons, despite Cassini's huge scientific legacy. Perhaps another spacecraft will get a first-hand glimpse at the space station one day. A spectral signal of something that appeared to be phosphine was discovered in the clouds of Venus in September 2020 by Jane Greaves of Cardiff University. Given the planet's oxidizing atmosphere, it should be impossible for phosphine to exist. Any phosphorus present would be oxidized to phosphate or phosphoric acid in the presence of oxygen. The scientists investigated abiotic processes that could be responsible for the production of phosphine, but none were able to explain the levels found. According to them, it was either an unknown chemistry or a kind of life. After all, phosphine on Earth is produced as a consequence of the decomposition of organic matter. Enceladus, one of Saturn's moons, is currently the focus of scientific inquiry. Hydrothermal vents at its bottom emit plumes of material that rise up through breaches in the ice and into space, and it has an ocean beneath an ice shell to support it. In 2015, the Cassini satellite mission collected samples from these plumes, which revealed significant concentrations of hydrogen and methane. So much of it, in fact, that Regis Ferrer of the University of Arizona in the United States and colleagues speculate that it could be produced by living beings. According to the results of their computational modeling tests, abiotic chemical processes are unable to properly explain the levels of methane detected. Enceladus appears to be a more hospitable planet than Venus in terms of habitability. Researchers claimed in 2018 that bacteria that live in Earth's hydrothermal vents might likely thrive in Enceladus's vents as well, based on their previous studies. Venus, on the other hand, appears to be too hot, with an average temperature of almost 500 degrees Celsius, and too dry to support life. That's it for today. Thanks for watching, and we'd love to keep you posted on all our future videos. So hit the subscribe button and the bell icon to be a part of our Facts Pulse family.